What was the hardest part about making that transition and working for a software vendor?
When we do PhDs and grad school studies, your role is to push the boundary of the theory or the application, right? That's a very different mindset when you transition to commercial side. We actually have to apply CFD to a very practical problem that drive business value. Maybe all you care is the delta between two different designs to get insights rather than the absolute value of how accurate a solution is, so that we don't have infinite time in the world to solve all the problems. So we have to find a practical solution so we can actually have some value, right?
In today's episode, I'll be interviewing Peter Liu. Peter received his PhD from the University of Michigan and began working for Comsol and then Rescale, and recently joined Luminary Cloud. I hope you enjoy our conversation, and please like, subscribe, and hit the bell so you don't miss an episode. Welcome, Peter. Thank you so much for joining the show.
Thank you for having me. Excited to have a chat.
Absolutely. So let's just dive right into it. Can you briefly describe, starting at your first university course, can you give us a background of where you started and where you're at now?
Yeah, sure. I might actually have to go a little bit further than that because I think my whole career around, I have a huge passion about aerospace and airplane. And it's kind of funny that my very first memory that I can remember was actually when I was 3 years old, riding the airplane for the first time. And that somehow stuck with me. And I can still have that, kind of imagine that feeling of excitement, right? And ever since I've been really into all things airplanes and aerospace. And that's why I decided to pursue a career and started with having my degree at the University of Michigan in aerospace. When I first started there, you don't really pick a particular direction when you first start, in undergrad. So, but I think the very first class that really struck me was my first aerodynamic class with Professor Chris Vikowski. He's an amazing professor and teacher, by the way. Like, he just explained things in such easy to understand term and really drive me interest into aerodynamics. And so in my grad school, I decided to continue to pursue that direction. And I was quite fortunate to study aerodynamics with some of the legends in the space. So I did my compressible flow course with Professor Leer, and my turbulence course was Professor Rowe. And they're just super inspirational people. And the class is quite interesting. I remember one of the class was Professor Rowe that, he's explaining, turbulence flow and the cascading of turbulence and all that stuff. And, one of the class, he just woke up to the whiteboard when he come into the classroom and start deriving equations. And I'm not very good at math, by the way. So halfway through the course, I still don't know which chapter he's talking about. And I finally realized, he's talking about chapter 11 about this. So I struggle a little bit, but I think was just kind of pure math aspect of it. But, I'm quite excited about, to see, even the Navier-Stokes equation, right? Like the closure problem, Navier-Stokes, and all the crazy, interesting way people come up with turbulence model to close a system. And it's amazing, like how it's more of a practical engineering and to make Navier-Stokes equation useful to do, RENs. So that's really drive me interest into aerodynamics. And I really got into, and I think particularly got into the application side of aerodynamics. I think once you're classically trained aerodynamicist in a way, right, you look at the world very differently. So, most people look at I don't know if you can find an object. You look at an object, you see is some form, but we can see, okay, there's a stagnation point here. There's some weight coming off here. It's kind of, you look at it world very differently because fluids, you can't see it. You have to imagine it, what it look like, and that's it's kind of the beauty to me. It's quite interesting. My grad school, I got into research related to CFD and optimization. And that's really, I kind of got deep into CFD. So at the time, I developed a RENs adjoint able to do design optimization. So I was at the group with Professor Kim Martin at University of Michigan called MDO Lab. And I'm quite fortunate to work on a lot of interesting problems on the application side. So I work on the blended wing body aircraft and to do shape optimization. I work on a problem which is a morphing trailing edge wing. So you can actually adapt the flap or a continuous flap based on a flight condition. I work on this geometry called Common Research Model, which is a Boeing 777-like geometry to do design optimization of the wing. So spent a lot of time writing Fortran codes back in the days, some Python. And so after grad school, I joined a company called ComSol, which they do multi-physics simulation. I think it's an amazing experience. I developed appreciation that, coming out of grad school, you're like really, really narrow in a particular domain, which in my case is aerodynamics, particular external aerodynamics for airplanes. And ComSol is a multi-physics tool. So I develop appreciation how simulation can be applied in all kinds of places, right? So everything from oil and gas, medical devices, microfluidics, for example, or electronic cooling and things like that. It's quite interesting to see the interaction and the coupling between different physics, and you can run simulation together. And then after that, I start into my startup journey. So I joined a company called Rescale. I joined quite early on and helped build out the field team on the what we call solution architects, which is a team that really focus on helping solve customer problem and help them onboard onto the platform. That's also me kind of venturing to the cloud journey. At the time, HPC is now really yet on the cloud. It's sort of the beginning phase of that journey. But it's quite interesting to see the different cloud adoption, in the simulation space. And more recently, I joined a company called Luminary about a year and a half ago, which I'm sure we can talk a little bit more about that. But it's another startup that more focused on CFD and develop a CFD platform.
Awesome introduction. And there's so much we can unpack in this podcast. But one of the things I want to come back to is you talked about working with Professor Rowe and Van Leer. What were there any like nuggets that they left you with that walking away, you look back and you have the hindsight, right? I know in times when I've met people that are really impressive, it changes you in a way, right? And you look back and you realize, wow, that was an awesome experience. Were there any things that stand out to you about being able to work with them or learn from them?
Yeah, absolutely. I mean, they're the legends. There's so much to learn, and from both of them, or actually many of professors when I had a chance to take class with. So it's quite inspirational when Professor Rowe teaching us about Rowe method, like a method named after him, right? So it's kind of the moments like, wow, that's like, and he's super humble, I'm. And the way he explained things and he treat every student amazingly. Like, if you have any questions, you don't feel like he's, a legend have been developing, Van Leer, for example, as well, that he developed the muscle scheme, right? Which is a very well known in the CFD space. So they're just very humble people and very amazing. And I think that helped me develop appreciation of, sort of, there's a lot of things can happen in life, right? And I think that, academia is one of them. And I think it's just amazing to kind of learn from those inspirational people.
Yeah, that's awesome. I love that you point out humility. I had the opportunity to meet Milovan Peric about a year ago, and I just felt the same way. Like there was no condescending or anything. It was just they're as kind as they are brilliant, and it's really impressive to meet someone like that. So it's awesome.
And Professor Van Leer play amazing piano. I think there's a YouTube video out there that you guys can find.
Okay, that's awesome. We'll have to link that in the show notes here when we find it. So transitioning a little bit, and you touch on this, but what was the hardest part, right? You've received this academic training, right? External aero and airplanes, and then you transition to ComSol. What was the hardest part about making that transition and working for a software vendor?
Yeah, absolutely. I think in academia world, right, when we do PhDs and grad school studies, your role is to push the boundary of the theory or the application, right? So like imagine this is the current state of art. Your PhD may make a little bit push it beyond what the state of art is. And that's what PhD is all about. That's a very different mindset when you transition to on the commercial side or on the of kind of how things operates, right? So most customer don't really, I mean, to be fair, it is important, but care less about that little push you made. Rather, they're using CFD to solve practical problem. I think that lets you develop appreciation. That's actually really, really important, right? So we can't have the mindset of just pushing that little boundary. We actually have to apply CFD to a very practical problem that drive business value. And a simple example could be if, in academia, you would say, okay, I need to converge this thing to 10 to the minus 6 or 7, right? Because that's the accuracy you need. While in practice, maybe -2, -3 is enough. Maybe all you care is the delta between two different designs to get insights rather than the absolute value of how accurate a solution is. It just let you think a little bit differently. And when I first joined Comsol, I was in a team that's customer facing, helping customers use the tool and solve some problems. And that's my first sort of transition is really kind of have to think really differently, right? So that we don't have infinite time in the world to solve all the problems. So we have to find a practical solution so we can actually have some value, right, out of those simulations.
Yeah. It's interesting you point that out. I recently had found a lecture given by Professor Rowe, and one of the things he talked about was inaccurate CFD can still be very useful. And he gave the example of how, I think it was the Airbus model, one of them was improved the drag by 30%. By what he was terming at the time, very inaccurate CFD, because they were looking at the trends, right? And obviously they did more testing to validate, but just exactly what you're saying.
Yeah, I just want to point out, because I think that relates to my experience doing design optimization. So trends actually is more important than absolute value in most of the design contexts, right? So when you apply a optimization algorithm to CFD, it's really just looking at the gradients, the trends of how moving this surface change design in that direction, rather than absolute accuracy of CFD. And so I think that's a mindset that we have to change quite a bit, right? Applying CFD in practical engineering problems.
Yeah, absolutely. So how did you handle not feeling ready for challenges, right? I think one of the other things we inherently pick up in academia is this idea that we need to prepare, and then go do. And in industry, again, because of the timelines, we don't always have that luxury. So how did you tackle not feeling like you were ready, but just diving in anyway with handling and being the front lines really of the software of tackling customer issues and problems that your customers are facing?
Yeah, I think that common apply both to industry, but also apply to startups as well, right? So one of the things I often say to my team is that we just have to be comfortable with the uncomfortable. You will never be ready. Like, we can prepare all day long. There's always some scenario that come up that may throw a curveball at you, right? So that oftentimes we just have to take that leap of faith. So whether that apply to a customer scenario where, hey, we just have to try this and to figure it out, rather than do all the research to understand all the theory behind and apply that to the problem. We just have to try it, right? And then we'll learn. It become a more of a iterative process. And one of the great mindset, I think, working in a startup environment as well, help to develop, and working in industry as well, is that just be comfortable. There's just never going to be absolute 100% readiness, right? Whatever you do, whether it's in your career or in personal life as well. And I think that moment where you just tell yourself, take that leap of faith and be okay with the failing, right? So the best way you learn sometimes is actually fail a couple of times, then you figure out the right way to do. And that's important. I think, apply to both personal life and career as well.
Yeah, absolutely. I know that there's a lot of psychology in this space. Recently, I was reading a book by Adam Grant. It's called Hidden Potential. And one of the things he talks about, he has these two charts, and he talks about how what you think is going to happen by being like prepared versus what actually happens. And it's never as bad as we think. Like, there are some cases where you need to prepare more than others, but just by getting in the arena per se, that's where you really start to learn and get better. So great insight. Another question, so focused on the PhD, looking back with the experience you have now, right? One of the questions that I know a lot of our listeners have is it necessary to get a PhD, right? And the answer is, well, absolutely not. It totally depends what you want to do. And I think, but what are some of the things that you've seen of how your PhD has influenced your career now that you've got years you can look back on and see that impact?
Yeah, my answer might be a little bit controversial, but I think what I learned the most from my academia career is not the knowledge itself, right? So particularly if you're working in a industry or domain that's very fast moving, what you know right now almost doesn't matter because 5 years later, it'll become very different, right? Back in the days of PhD, there's no cloud or very few things running on the cloud. Nobody running CFD on GPUs at the time. Everything's just very, very different. So rather, what I realized was valuable is actually the process of learning. Like you went through the journey in whether it's grad school or just undergrad assignments, you are given a goal, right? And it's up to you to read the paper, do the research, write some codes, try things out in order to figure that goal out. And you repeat that process many, many times through all your PhD career or even just undergrad doing some assignments. And that muscle memory of the ability to take a task, take an angle and figure out the step you have to take and spend effort to do research, read papers, look up things. And in the end of the day, hopefully you hit the goal. If not, maybe fail a few times. Then you keep repeating that iteration until you hit a goal. That journey is what valuable to me, right? So, during a PhD, you have to struggle so much time. I can't remember how many nights I've been up, tried to debug my code. And then I think I have to rewrite code many, many times until actually, I find out that issue is. That struggle, that journey, it stuck with you. And, later in your career, it's the same thing in the end of the day, right? So whether you have a challenge with certain customer problems that you have to do the research and figure it out, that whole process become your muscle memory, and that's gonna carry for your entire career. That you become a problem solver, right? Able to have the ability to learn, adapt, and then find a solution at the end.
Yeah, that's excellent. Excellent insight. There's a quote, I think it's been misquoted by Darwin, but I just came across this recently. It was someone summarizing Darwin's stuff, and he said, one of his summaries of reading Darwin's work was, "It is not the most intelligent of the species that survives, but those that are most able to adapt." And as you're talking about that, I just think that's exactly it, right? Like, there's so many people smarter than me. But one of the things I have learned, and like you described, was those who are able to adapt and to continue learning. So, excellent point, especially, and things are only accelerating too. And I'm sure we'll touch on that more as we get into industry trends and whatnot. But excellent insight. So, right now, your role at Luminary Cloud and in previous stuff, it's been more of a what some might call a technical sales role.
Sure.
Right. And what do you think are misconceptions that we have in this industry about technical sales?
Many people scared with the term sales, right? Like that word. And it's actually kind of funny that when we do recruiting as well, we don't use that term at all because it may actually scare away candidates that highly qualified, can do the job really, really well, but they perceive this being a sales role. And it's like, nah, I'm not in sales. Like that's not me, right? So
Yeah.
in fact, my team, we call it solution engineering and explain a minute why, but the sales process has changed tremendously, especially the technology sale in modern days, right? It's not about you're knocking on the door, doing cold calls and none of that. I mean, maybe some of it a little bit, but it's not the goal of sales anymore. And in the end of the day, our role is actually what I call solutioning, right? So what actually make the sale is not your best sell person in the world, is actually you can solve a practical problem. You can solve a pain point for your customer. And that actually come down to a fairly technical level for a product like CFD or most of the highly technical product, is that your role is to, understand what customers doing today, how they're running simulation, type of simulation they're running, the bottleneck they're seeing, whether it's, they need to add more accurate results or they're not able to get enough throughput on simulation or whatever that might be. And the role of technical sales is actually come up with a solution where you can help them solve those pain points. So it changes quite a bit, right? So that's why we don't keep the sales hat on in our role. Because in the end of the day, what we're doing is not sales. We're solutioning. We're helping customer figure out how can do things better. And the sales come naturally with it, right? If they can get a value out of your tool and they can justify it, there's no reason we're not moving forward. So there's a lot of, I think that a lot of people in the industry are very smart and can be very qualified for the role because they may get scared away a little bit by the term of technical sales. And I would love to encourage people to reconsider that because this is a very fun role, right? You're not really sales in a way that in a traditional sense, you're really solving problem. Every day, it's quite exciting that, you talk to different customers, they run CFD or use CFD in different part of their processes, and they have different type of pain points. And it's go back to the problem solving skills where we the exercise is to help figure out, okay, how can we solve the pain point? How can we solve the bottleneck they have today?
Yeah, that's excellent description. I love how you describe that. One of the things, I'm sure many listeners don't know this about me, but I did spend a summer doing door-to-door sales after my wife and I got married. And I loved the experience, ironically. And I think so many people are shocked by that because one of the things I did learn, and obviously that was definitely more sales than what you were talking about, right? It was not technical sales, but that was one of the things that has stuck with me throughout my engineering training was the importance of conveying the value that you're actually solving a problem that they have. And it was such a formative process for me reflecting back on it that uh, there's so much, and you talk about this, right? It's exciting and it's fun when you see, I won't say that the pest control was that exciting, but in CFD, it is exciting and fun to help others solve problems and to unlock value that they have previously not been able to unlock for whatever reason.
Yes,
So no,
totally. Pest is also a very important problem to solve, by the way. So it's equally, or maybe some more important if there's an issue. So, but I think it go back to like to me, oftentimes engaging with the customer, it's like the peeled onion effect, right? So that you learn a little bit more every time you have a conversation, you understand what the challenges are, and then you formulate a solution. And it's actually a great feeling. You're actually providing value to them, right? In the end of the day, they can run more simulation, better design, faster time to markets. And when the end product, whatever it's a car or airplane, whatever that is hit the market, it's a very proud moment, for someone like in technical sales that you actually help throughout that journey.
yeah. I think this is so switching gears here a little bit, but still on this value solution providing context. So I think I came across this paper. It's an old paper for many people, I'm sure, but for me, I just came across it last year. It was a paper Boeing wrote
Mhm.
in 2004, 30 years of CFD at Boeing commercial airplanes. And one of the things that they really focus on in the paper is that for Boeing to get the value out of it, they had to convince the team internally how this was going to help their design process. And so they walked through these phases of CFD adoption for at least how it went for Boeing, right? And there was what they describe as the first phase. There's this gee whiz that you see, look what we can do. And that's maybe what happens more in academia, right? They're pushing the envelope. Look at this claim, look what we can do. And then there's the next phase of, okay, how do we implement this at scale? And then there's the execution phase where you are reaping the benefit because you've implemented it at
Right.
scale in a streamlined process with all your other tools you're using in this production lifecycle. And one of the things that they claim, though, is that yeah, so just quantifying the value of
Yeah.
CFD and how is that done? So can you speak to that in your experience? What are things you've learned about quantifying the value of CFD for companies?
Yeah, that's actually one of the most important part in technical sales, right? That you actually the angle you're solutioning something, but that solutioning something has to have a quantifiable value. And Boeing is quite advanced in the adoption of CFD, obviously compared to most company out there. So and you can imagine that how hard it is to justify. So sometimes when we talk to the users of CFD communities, they sometimes even themselves have a hard time to justify to their management why we need to invest into doing CFD versus some other area, right? So And that's part of the process we have to go through to quantify the value of CFD. And in the end of the day, the person who signed the bill may not even know what CFD is. And all they care about in the end of the day is time, money in some form. And we have to translate all the things we're doing into time and money, right? And then somehow we to quantify that. So every company is a little bit different. So traditionally, if you haven't adopted CFD, usually the value comes in terms of faster time to design, faster time to market, and the lower cost to development, right? So traditionally, whatever product that is, oftentimes involve physical testing. And CFD is not unique, but mostly simulation's role is to replace that, which typically will shrink the design cycle, but also you able to try more what if scenarios to perhaps get a better design out of it. And that translates to one, cost saving. Experiments are expensive. And two, is translating to time to market, which is a little bit hard to quantify sometimes, right? So what it means to get your product out to the market a month earlier than your competitor. And we often have to work through that market value to do that. So, like I said, it's a little bit different from the customer. So one of the process we develop at Luminary and at Rescale in the past as well is that you have to go through that, the sort of value assessment, right? So that every customer we talk to, we peel the onion to understand their current process. But we also want to help them to justify investment into CFD. And we often will help actually lay out what are the quantifiable value it is. And, usually they might make a pitch to their leadership and such, and to help justify that. The other process that's maybe the unique to Luminary or any consumption-based business model is that the value to a software vendor is actually when the customer actually using your product and getting some value out of it, right? So honestly, we care less about selling them initially, because that doesn't matter to me until they actually seeing the benefit of using Luminary or any software that they purchase and making that impact in the business. So we actually develop a function we call custom success, which is sort of come from the SaaS space. But in the pre-sale stage, we need to quantify the value. In the post-sale stage, that's equally important. We're not just close the deal and then move on. We actually really even put more time in there to make sure they're actually using the product effectively to actually hit the business value. So we develop things joint success plan to able to say, okay, with this tool, these are the business value that we can get. These are how we quantify that. And as we continue with customer as they use the tool, we actually measure that and, see how we're doing right against that initial set that we do. So, it's quite interesting that, we have to, translating a CFD tool into a business value. But I think if we can summarize it in short, most of the translation probably will come down to time to market, time, and then money, right? Cost in the end.
Yeah, no, that was a great summary. Excellent summary of that. And I think, especially for people new to the field, understanding how important this concept is, I think it's just completely overlooked, right? Because many times, maybe in undergrad, you took a business course for some breadth or something, but this is such a critical piece of why some companies are more successful than others. And I can just give an example of being on the other side of that. I have had CFD vendors reach out to me and set up some of these exploratory pre-sales calls with me. And I am amazed at the contrast in the way some of them prepare. Some of them prepared, they knew my industry. They knew exactly what problems I was trying to solve. They had an idea, at least a guess of what my bottlenecks were. And others came with a boilerplate, like classical problem.
Yeah.
And it was just obvious to me. And it was so striking to me of how they were unable to see what it looked like on my end. Yeah. And there was almost some shock that I was like, no, I'm not wanting to proceed. Like, you don't even know what industry I'm in. Like, you're solving a problem that is interesting, but not even in my space. Like,
I'm glad you mentioned that. I personally actually made that mistake early in my career as well, right? So that because you're very comfortable with the tool that you work with. And when you go to a customer, you may immediately think about, I want to have this laundry list of all the features that I have to impress them, and in the hope they will buy the tool, right? That's not how things works in reality, right? Because customer interested in talking to you because you can help them in some way in their business. So we have to actually think from the customer's perspective, why they're actually talking to us, right? What problem they may have or bottleneck they have, and how our tool can help them solve those bottlenecks. Sometimes actually have nothing to do with the feature functionality. It eventually will translate into some feature functionality you have to do to run those simulation, but that's much later in the conversation, right? To realize those value, you have to go through those things. But yeah, I think to your point, it's quite interesting that contract as well, because I've made mistake myself early in the career. I'm doing exactly that, and that's not a very effective way of working with customers.
Yeah. And there's a line in that Boeing paper that it goes something like this, that the development team learned they couldn't throw a new feature over the fence to the design engineers and expect it to work and expect them to start using it. And I just loved the way they talked about that. Like, here, it's done. We'll toss it over the fence to the other team. They'll take it and run with it. But it was a very tight collaboration, even internally. When you're doing this internally in a company of Boeing size, the way they describe it, it was very, very collaborative. So excellent insight. Switching gears here a little bit, we talked about learnings and mentorship in the PhD, but as you've been in your career, maybe who's been your most important professional mentor? And maybe it was from the PhD, but who has that been, and what role have they served for you?
Wow, it's really hard to narrow down to one. I think I'm quite fortunate. I work with a lot of smart people that helped me tremendously along my career. So, even from the early days, even some of my lab mates that, like Gaten Kenway, for example, he helped me a lot in my grad school, and Walter Fry from ComSol, and Uris, Matt McKee, Fanny, and many others at Rescale that took a chance at me, and then Juan Lozo and Jason Lango and many others at Luminary as well. So, but if I think if I were to pick one, I think maybe not professionally speaking, but the person who impacted me the most throughout my career actually is my professor, what I studied my grad school with, Kim Martin. So he, I think my mindset has influenced a lot by him. So, he if you don't know him, but he's an expert in MDO, multidisciplinary design optimization. I took aircraft design class with him. I took the design optimization class with him. I think the most impactful, there's two areas he impacted me most. One is that we both follow a person called Dumont a lot, which he's in the field of technical communication. So, in grad school, right, you would write a lot of papers, you would do a lot of diagrams. And one of the things that we look for is actually how can we summarize that information in the most simplest way and showcase in a graph in the easiest way to understand. Remove all the noise. That actually carry to my career a lot as well. In technical sales, that's what you're doing. You actually need to communicate something in a most simple way and simple terms, right, to customers. So Kim Martin is a big fan of that. And he pushed me really hard. And in terms of all my plots I'm doing, all my presentation I'm doing, I don't know if you can look up some of my early paper compared to some of the paper I wrote toward the end of my PhDs. It's so different in terms of the plots I'm doing and even the presentation I was making, that I adopt a style where if that piece of information is not useful, it's a noise, right? You want to remove it as much as you can. Every slide needs to have a message, and whatever you put in that slide or graph has to be relayed to the message you want to deliver. And I kind of really changed how I do communication. And thanks to Kim Martin, that pushing me hard on that aspect. And he himself as well followed that quite well. The other aspect, I think it's kind of funny to say, but he and I are alike in many ways, right? So one of the things I learned a lot is that this whole concept of design optimization, and I try to apply it to my personal life as well, because I think your life journey is a constraint optimization problem in the end of the day, right? You have some objective function and goal in your life you want to achieve. You have constraint you have to work with. So there's a boundary you have to work within. And your life goal is to find a path to get to that as close, maybe not exactly there, but as close as possible to that optimal, right? You want to hit that goal you want to achieve. We at the time I learned a lot about gradient-based optimization, algorithm, and things like that. And it's kind of funny to see that actually can apply to your life and to your day to day, right? So everything you do from personal finance to your career movement and things like that can also be applied as a optimization problem you solve. And there's a concept of gradient-based optimization where it's usually more efficient compared to non-gradient-based optimization. But if you apply that to your life, is that non-gradient-based optimization is like, oh, I tried 10 different things or 100 different things. Then I'm trying to pick the one that's the best, and then I tried another bunch of things. Then I figure out what I can do the best, right? And kind of keep iterating that way. As opposed to a gradient-based optimization is to start somewhere. You try something that's related to your field, related to your field of study. And you see, okay, am I doing better here? Or am I, you figure out the gradients, you figure out the slope where you can make the most progress in your life or in your career. And then you keep following that trend, following that trajectory all the way to get closer to the optimal. And I thought about it as like, yeah, that's exactly how things can be applied in life. And that's why I try to apply myself as well is, starting a career in simulation CFD, venture a little bit into, let's say, cloud, and maybe now more into perhaps AI, we can talk about in a minute, but like there's different area that's adjacent to it that you can venture into and help you find the optimal, and that way can make the most impact in your career.
Yeah, it's fascinating. I've heard and read a lot of business books, but I've never heard them talk about it from that technical of a level of like a gradient-based optimization. So I love that. That's so awesome. Thank you for sharing that. What's been one of the most difficult professional challenges that you've had, Peter? And how did you overcome it? And maybe there's not one. Again, I realize the mentor question probably isn't fair either, but thank you for answering.
No, all good. So I think looking back at my career, I had my first leadership role, manager role at Comsol, and later at Rescale is where we really developed my career, and managing a large team. So I think that journey going from a individual contributor to a leader is actually quite hard. And I think many people may not realize that how hard it is, especially in a technical role, right? So that, you are, as I see, you're treated as a technical expert, right? You're there, hands on keyboard to solve the problem. And when I'm moving to a leadership role, you only have this much time, right? So there's so much things going on. And early in my career, I tried to be what you use this term super SA. So like I tried to be a leader, running the team, but also be more hands on keyboard, nearly burn myself out. It's not the best idea, right? So because you have to trade, you have to give up something. So one of the hardest choices I have to make is actually give up a lot of my time to do hands on keyboard, which, obviously many of the technical role people will really enjoy, but realizing that, because if you do both, you're not doing either really, really well. And you're just compromising, and you're not, that's not the role anymore. You have to sort of take a step back. So I ended up having really hard to give up that. And then, trusting the team, trusting the smart people around you are actually going to do this and do this better than you. And your role shift quite a bit is instead of actually hands-on keyboard solving that problem, you're a facilitator, right? You're a facilitator to help them remove blockers, to help them get the support they need and help them solve the problem. That journey, that transition was super hard. It took me a while to get used to. And as you grow your career, and that become even more extreme, right? So that you may leading a few managers that even themselves may be a little bit less detached from the day to day. So that thinking about what the business outcome you want to achieve, how you can apply your own value, and then have to say no and give up a little bit of time or quite a bit of time on all those hands-on keyboard, but still stay relevant. You have to still learning the industry. Once in a while try things out. That balance is really, really hard, and I think it took me perhaps a year or two at least to find that balance. Maybe even today, I'm not that good in terms of balance yet, but I think it's a journey that we have to work through going from IC to a leader role.
Yeah. Yeah, I'm so glad you talk about that. One of my favorite books is by Greg McEwen, and it's definitely like pure business book, but it's called Essentialism. And one of the themes that he has is just the reality of trade-offs. And I loved it. I think you quoted exactly from the book that if you're doing both, you're not doing either one well. And I think that uh, that's a hard mindset for many people. I know it has been for me and for others that I've worked with in this space, in simulation space, because we love the technical so much, right? Like as you're transitioning to whatever role, maybe it's um yeah, just the ability to say no is actually a very critical ability the farther you go in your career, and just to decide what those trade-offs are going to be. So
Yeah, I just want to
excellent,
add a
excellent.
comment that it does
Yeah.
the career path I choose, right? That doesn't mean the only path. So I definitely see a lot of people are successful choosing the technical path as well, right? So that they can go deep, doing more hands-on keyboard. It's really, you have to think about what you want to do for a career and what matters the most to you. Um, so talking about books, there's this book called A Range by David Epstein, I think, that I really love that book as well. That talk about, I end up choosing a path that to go the width.
T.
Yeah, exactly. So
Yeah.
going that direction, but it's equally well, you can choose this path going deep, right? And it's really up to individual person to pick the right best career path for them.
Yeah. I think just the point making that whatever one you pick, you've just got to make it with both eyes open, right? You're giving up something and just be comfortable with that. So yeah, excellent. Um, Transitioning gears a little bit more to general industry trends and whatnot. What trends, right? You've been in the the cloud space for a while and seeing this migration and this transition. What are the trends that you're seeing now? And maybe you could just speak to the acceleration of those trends, or what are we seeing with the simulation space from your angle?
Yeah, for sure. I think this is an exciting time for us in this space, and I'll explain why. But uh, simulation traditionally hasn't changed as much, right? Let's say for the last decade or so in the past. Um, when I joined Rescale at the time, that I see that being the first change in our industry, going from running on-prem to taking the advantage of benefit of the cloud. So that transition, going from running on-prem to cloud is still today is still in progress. So when I first started Rescale, nobody running on the cloud at all. Like that's like nearly I won't say who told me this, but a person that very close to me told me HPC will never move to the cloud. That person is a deep expert in HPC. So, and I think looking back, I actually not quite sure at the time as well. Like I go back to our comment earlier. I took that leap of faith, going to Rescale, saying, "Hey, I think there's something there, right? There's benefit, and maybe someday simulation is gonna move to the cloud." And fast forward to now, more and more people are adopting cloud for HPC for simulation, and now we're at this. It used to be a tailwind. Headwind on that adoption. Now it's a tailwind because everything around us already moved to the cloud, and HPC at some point will, if not all of them, but a big portion of them will be running on the cloud. So that's one trend that we're seeing a lot is that cloud journey. With cloud, there's come its own challenges, right? So that Rescale and a company like such are helping solve those challenges. But I think the benefit is super clear. That the thing with engineering workloads, the demand is really peaky, right? So you're never always going to be wrong. I'm always going to run 5 simulation every single day, every single time. It's never like that. You always have some projects where you may run a design experiment or try a lot of different what if scenarios, and a period of time that, hey, I'm focusing on something else, right? I'm not going to run any simulation. And the cloud is a very natural fit for that kind of a consumption pattern. And it's just a matter of time that I think more and more people will realize that and moving to the cloud to run the simulations. The other trend, obviously, we can avoid the topic of AI. So it's all around us. Generative AI has made such impact to our day-to-day already, and probably even more going forward. And everybody in our space probably is thinking how AI can apply to CFD, right? So I've been thinking a lot of that as well myself, and both as at Luminary as well, and thinking about how that applied to the product as well. So um, I think we're in the early stage right now. And to me, I think AI can be really useful if there's a practical value, right? There is a value we can drive. So I'm not have this elusive dream of actually one time we're thinking about if you have enough data of CFD data and tons of them, right? And in theory, you can train a model to replace CFD simulation. You have this holy grail of model that just contain all the information, all the different, all the physics and the different kind of geometry. In the future, if you have that holy grail of model, then you can just do inference. You don't need CFD anymore. It takes seconds, right, to do inference on most of that. But if you do the back of napkin math, the amount of data you need to achieve that, it's multiple order of magnitude larger than what they're actually doing for generative AI to train that model. It's just way far out there. Maybe someday, I'm hopeful someday we'll get there, but it's not in practical today that we can do that. Right? What is actually practical today is for a subset of problem, a very well-defined problem, you can already achieve that. Many companies out there today is already have a product developed toward that direction. The other area where AI can apply is in the day-to-day workflow of simulation. Can we make the life of simulation engineer or CFD engineer easier by providing them some guidance on how to set up the model, or providing them some assistance, clean up geometry and things like that. So I see a lot of trends in AI, but I think the holy grail is there. But in the near term is really, we have to be very practically oriented, how AI can be helpful in the day-to-day, right, in the simulation workflow.
Yeah. And I love how you point out people are already doing this for a subset. I think what I see, and I try to read broadly at different opinions of experts and stuff, but I see there's these people that are similar to the mindset of HPC will never go to the cloud. Like AI is never going to come. But then there's also the claims of, so somewhere in between. So it's just nice to see examples of what's happening and from your side. So how does this relate to Luminary Cloud? Like what is Luminary Cloud's vision for CFD? You've touched on it briefly, but maybe you could expound a little more.
Yeah, absolutely. I remember in my grad school, like I was running on some of the simulation that take hours, and the whole optimization can take days to complete. And that design cycle just very long. So you set up something, you get insights 2 days later, and then you keep iterating. What we want to bring to is what we call real-time engineering, is that you can get insights right away, right? Ideally real-time, if not near real-time in the order of seconds, maybe minutes, not days is the range we're talking about. There's a lot of technology today can help empower that. So we talk about cloud a lot, but also GPUs or accelerated computing resources actually can change the equation quite a bit. With all the advancement in GPUs, every new generation of GPU being released right now is nearly doubling the memory bandwidth, which is usually sometimes the bottleneck for CFD running on GPU. So we're also in a situation of a tailwind situation that all these things come together, actually empower us to be able to run those simulations, high fidelity ones, that's very fast and have those insights very quickly. So what Luminary Cloud do is that we actually combining all these components together. We're combining the underlying cloud infrastructure, a very easy to use SaaS interface and experience, like a Gmail, as easy as that in browser, as well as an extremely fast solver that we have developed from scratch that's based on accelerated compute. And all these components connected together to give user experience to be able to run those what if scenario, right? All these type of design questions and in high fidelity, RANs, LES, DDES type of range, able to get those design insights very, very quickly. So it's quite exciting. We're at the beginning of our journey, being a new kid on the block, and we're rapidly expanding our capability as well and to cover that. And I think our hope is that we really, in the end of the day, help industry to shrink that whole time to insight time to able to, every engineer can ask the question, hey, what if I add this component to my geometry? And he or she can get an answer in minutes or seconds, ideally, not days and hours.
Yeah, that's That's exciting. That's so exciting. Two comments that come to mind. One is, again, this is from that Rowe lecture that I watched, Professor Rowe. One of the things he said was one of the benefits that Airbus was talking about with CFD was the ability to, he said, you're going to look stupid if you set up a wind tunnel and you have this crazy idea and you get everything set up and then it just fails. You're going to feel really foolish. But when you can do that in CFD, and you can get feedback. Nobody even knows if it was garbage. You don't have to share it with anyone, right? And so
Yeah.
Airbus felt like it expanded their creativity. But then even coming to this again of being able to test that in minutes and get the feedback on those crazy ideas per se of more innovation. And then the other one, which I want to transition to, one of the things that was also highlighted in that Boeing paper was, and this was again, just the way that Boeing had recounted their experience, but they said, I think it was about 100 to 200 CFD runs were run in 1973 for Boeing commercial airplanes. And by the 2002 or 2004, it was estimated that over 20,000 runs were being made annually. So that's a jump of 2 orders of magnitude. And 90% of those runs were being made by non-CFD experts, right? The design team. They had fully integrated it into a package. So that was they didn't use this phrase, but now we use this phrase, the democratization of CFD, right? So for you and for your perspective, Peter, what are the key components to democratizing CFD? If we look at that as beyond just a company, but
Yeah.
industries being able to democratize CFD.
Yeah, absolutely. I think that term has been around for quite a while. I think, the whole industry has tried very hard, actually, many iterations and different products all pushing that direction, right? So whether it's creating an app of sort, or easy to use interface and such. So my first comment is that it will actually expand the user. It's not going to change the user group, because in order to do hardcore sort of true, some of the design insights you do need someone has that experience and training, able to really get that insights and set up the problem in a way that you can get those insights. So it's not going to replace the CFD analysts and engineers. However, what I can see the value is actually extend CFD to upstream of the design process. So instead of that, you have to narrow down to a set of final-ish design or preliminary design, then running CFD and all that. You can actually push upstream to the designers that actually they can try some of the what if scenario, even though they're not classically training CFD, right? And that's the value I think industry see here is actually not replacing, but actually expanding that user base to more upstream in the design process. So, and that's not going to be easy task, because as you know, running CFD is not simple. There's so many knobs to tune, right? And if you mess up one knob, the results can be garbage. And then if you don't prepare the geometry correctly, garbage in, garbage out, right? So there's just so much thing to do to actually achieve that. And I think people may underestimate how hard that could be. So what I can see, there's a couple components there. So one, it has to be easy to use, right? So you can't expect a designer to know how to submit a job submission script, send that to HPC and all that stuff. It's not going to be possible. So we have to able to have an interface that as easy as Gmail or whatever, like web browser based apps that we all able to use, to the degree that, you don't need a 5-hour training to use Gmail, right? And we need to get to that goal of someone can actually just open the app. The app itself already have enough guidance and, foolproof in a way that building, someone just may not even need to read a menu, able to operate and run some of the runs. That's number one. The other one is related to all of those knobs we have to tune. So the inherent nature of CFD require those knobs, right? But there's a way we can automate some of those, right? So that we can, based on the type of geometry or type of inputs, automates that whole knob tuning thing that we often do in as a CFD analyst, and that take that component away, and to the degree that they can trust the results, and get the insights right away without having to worry about did I mess up the knobs and things like that. So, and lastly is the business model. That's actually not many people looking from that angle, because historically, right, the industry has always been a seat-based license model. That to me is an inhibitor to adoption, because you need to add more seats in order for more people to use it. And, many vendors out there today still operating that model, which, I can understand why it's kind of easy to operate that way. To me, the future really to empower democratization of CFD, you have to switch to a consumption basis model. You cannot add penalty for people who want to try new people into this domain, and you have to put on whatever dollar to actually get a new license, right? You have to really drive toward a consumption model. If they get value, obviously they'll run more. You recover your revenue. If they don't get a value, that's fine. The customer don't take a penalty in order to venture into that direction. So to me, these are all really key components. We're getting close, but I think we're still probably a few years away from maturing that, right? And able to really push CFD upstream in the design process.
Yeah. No, it's absolutely fascinating to hear these insights. And I know I've seen and talk about the consumption-based model, but I've never viewed it through the lens of it being an inhibitor to the democratization of CFD. So that's excellent. Maybe in closing here, if someone wants to get in touch with you, what's the best way to do that, Peter?
Yeah, no, absolutely. So I think I'm very fortunate to have many mentors and colleagues in the space that I work with, and happy to help anyone that interested in getting to CFD or helping with their career. So you can find me on LinkedIn. Probably that might be the best way to get a hold of me. If you're interested in Luminary or any of the technology we develop, please reach out to me as well. And we just come out of stills, and we're expanding our customer base quite rapidly. So love to show you anyone that interested to take a look.
Yeah, absolutely. Thank you so much. And we'll definitely put the LinkedIn profile and Luminary's website in the show notes for people to be able to jump right there. But thank you again for joining the podcast. Really enjoyed our discussion, and hopefully we'll have a round 2 in the not too distant future. So
that's all great. Thanks for having me.
Thank you for listening. Really, thank you. Did something about this episode stand out to you? If so, please go ahead and share it with others on LinkedIn or other social media so they can find this as well. See you next time.